that's on. Talked about OTs would recommend fidget spinners. Do you know the fidget spinners? And she said that drove her nuts because the kid would, one of the OTs recommended it, and the child, every time they used it, everybody in the class would look over. It was really distracting for everybody. And so we talked about that a little bit, and she said that from her experience, she felt that the fidget spinners were exciting, not calming. And often we use fidgets so that people can focus. So she said things like putty, or there's fidget boxes and stuff. Those are much better choices. And she said OT should never recommend fidget spinners for the classroom. And then we talked about a little bit how sometimes teachers within a school, you might work with 3 or 4 different teachers. You might have kids in 3 or 4 different classrooms, and teachers all have their personal preferences. And she said this was across the board. None of the teachers like these fidget things. And so the moral to that story was, so what does that tell us as OTs what we should always do?
Talk to the teacher.
Yes, so before you recommend anything for a classroom is make sure that you talk with the teacher. And also learning the culture, right? So things like this, there's cultures. And we've talked about the handwriting and how sometimes teachers want to do that, and sometimes the culture is that the OTs may do that. So those would be important. And then there was one, the last one was a child with severe autism. It was inclusion, and there were some children that needed a lot of one-on-one. So these are children that are included, but they can only be included if they have a one-on-one. And this was a 6th grader with severe autism, and he wouldn't follow directions and didn't really act like he felt part of the school or part of the class and any of that. And so this was the OT and the teacher really got together and talked about coming up with ideas. And one of the things that this young man liked was email. And so they decided that they would email him a job task every day. And so she said every morning he came in, he'd look at his email, he'd have his job for the day, and he was so excited, and he was really included. And it was things like cleaning the chalkboard, or leading the story, or taking out the trash, or whatever. But it was a task every day that was just his, and everybody in the class got to see that he had, his special thing. So I thought that was a really good example. So I just wanted to share those because someone had asked for them, and I thought those were good ones. And how many of you are doing your field work this semester? So 1, 2, 3, 4, 5. Okay. So what settings are you guys in?
I'm in an outpatient.
An outpatient, and over here?
Childhood center.
So 2 of you are in the early childhood this semester, okay? And
Inpatient rehab.
inpatient rehab, and then one over here?
I was at a school.
You were at a school? So do you have anything to add to the school stories? If not, that's fine.
Not that I can think of right now.
Okay, that's fine. And then for the other 4 of you, hospital and outpatient, have you had any great stories about things that others could learn from? Yeah?
I do, and then you go first.
Okay,
I
and
have a story.
where are you? I'm sorry.
It's okay. I'm doing hippotherapy, so I'm
Hippotherapy.
in schools, but there's a kid that we're seeing who has autism, but he recently got ankle surgery, so he's in a wheelchair. Just for like the next month or whatever. But he was just saying, we're like, how's school going? He's like, it's good, but I don't get to do anything in PE. He's like, I only get to do like arm movements and stuff. Like
Right.
everyone else is like playing around and stuff. So we just talked to him and to his parents
stories from field work?
I thought this was kind of like a cool direct connection to occupation. So we're working with a 15-year-old with TBI, and was in kind of like the very volatile stages. And so I asked my educator before going, I was like, do you have a game plan? She was like, whatever he wants to do is where session's gonna go. And so we walk in, and it was just like, before starting, Mom was like, he's not, like, I know he's capable of eating, but he continues to depend on me for feeding and opening his ketchup packets, and I'm just, is there any way we can just make that the focus? And it was like, boom, Mom knows what our role is, we know what our role is, so then we did like a fine motor task to just, with his right arm, which was affected with like a stroke that also was a part of everything. And so then it was just cool to be able to come back and prove to him through like, you just did so well in Connect 4, there's no reason that Mom needs to open your ketchup packets when you eat your hamburger tonight. And it like kind of took that where he was like, oh. And then it registered for him where he realized, and that was his homework, and he was like, yeah, I can do it, I can do it. And Mom was really happy because she was like, thank you. Like, I've been
She
fighting
really
him on this, and
appreciated
now
it,
we
yeah.
actually, like, he's proven it to himself that he can do it, so.
Right.
Yeah.
And it sounds like, you know, so it's interesting because, do you think he had the ability to do it before?
Yes.
So in that case, why do you think he was always asking for help?
I think it's a product of almost like learned helplessness to a degree, where you
Little
get in
bit.
this setting and you are doted on, and
Yeah.
Mom is doing everything for you. And I mean, he's obviously going through like a lot of confidence issues
Yeah.
right now too, where he's realizing, he's in this stage now where he's realizing his deficits. And so to be able to actively prove his capabilities to
Yes.
him is a really important piece.
Yeah, good. And so learned helplessness, but also the attention, right? He's going through a lot of hard things, and it's one way to get attention from your mother in a way that, you know, a 15-year-old usually doesn't probably. So,
Yeah.
good, excellent. And everybody was happy at the end, so that's good. Any other stories? What?
Best out of 3. Said, and he beat me. Best out of 3.
He beat you
Because he
too?
played it so fast that I like couldn't track and keep. So my educator was like, "Did you let him win?" I was like, "No, I literally could not beat him."
So that's it. So hold that thought, and that's a great thought too as we talk about inner drive. Because I mean, so he didn't have the drive to do that, right?
Mhm.
To do the catch-up stuff. So these are good examples to kind of feed into that discussion we'll have later too. So great. Any other? Anybody have any other stories they want to share from field work? Okay. So, so this week we're going to, gotta get my, we have some, getting to know each other, and, Abby and Simone. Abby's here. Is Simone?
She's not.
She's not? So let me see, so I think, Tim, I don't think you've gone, so we can have Abby and Tim do it, today, so let me just pull that up.
No.
And I think we have 2 left after that, and we'll do those next week.
She just like didn't even try it. She's good as she tries.
interesting. So which one do you think is the lie? So who thinks that that Abby being an illegitimate descendant of King Oscar is a lie?
I feel like that's true.
Okay. All right. All right. Who thinks that the lie is that Abby has an irrational fear of glass dolls?
Christmas is coming.
Oh. So that one might be the favorite. And then who thinks that who thinks the lie is that her parents locked her out of the pantry because she was a chow mama?
No one.
All right, so which is the lie?
So the lie is that I have an irrational fear of glass dolls.
Aww.
It's actually ventriloquist puppets. I find them horrifying, and I attempted to conquer my fear as a freshman in college by being a ventriloquist puppet for Halloween.
Oh.
But like the movie, the Goosebumps movie, Slappy the Dummy, like traumatized me, and I tried to watch it 2 Halloweens ago to like conquer my fear of Slappy the Dummy, and I had to turn it off. So I was like, this is triggering.
Well, I guess you know what your costume is.
And so the
So
top
are
one-
you a princess then?
I don't really. So my great grandma Torberg immigrated from Sweden, and we found out years later at a family reunion. We were going through looking at one of our family trees, and we saw King Oscar was on there. We were like, how is that possible? And so my great grandma Torberg's mom was a maid on King Oscar's quarters, and he was supposedly known for having a bunch of affairs, and so Torberg was descendant. Well, she was like his daughter, and then she moved to Illinois, and there were Swedish delegates. Story goes, these Swedish delegates came, and they like swore her to secrecy that she could never reveal the identity of her father because King Oscar was trying to cover his tracks. And now it's out.
And now it's really out.
He's on the, if you, I don't know the brand, but King Oscar is on a Swedish, or like a canned tuna. So, you ever see him? Grocery store. That's his photo. And then the third one is true. I could walk at 8 months, and I caused all sorts of trouble, and I would go into the pantry and like pull things off the shelf, and my mom would come in and find me, and I would just be nomming on everything that they had to lock the pantry because I had no self-control. And then those are my 3 songs. I love the Eagles. Easy's just a classic. And You've Got a Friend. Just this point in the semester, if anyone ever needs me or needs anything, I'm always here. So, interest with children, 4, and experience with children, 4. Did a lot of recreational therapy and respite care, and lots of camp counselors. Taught art camp, which was not good because I'm not an artist, and the kids used to cry. Miss Abby, you ruined it, when I would try and help them. So, and then fieldwork, Children's Hospital, inpatient rehab this year.
Okay, very good. Thank you, Princess Oscar.
Thank you.
And then let's just find Tim here. Oh, there we go. So Tim, you're on.
Okay. In 6th grade, I did a backflip off a jungle gym and broke my spine in 3 places. That same year, my older brother broke his back at a track and field event. We're both a little shorter than we would be, but otherwise okay. Thanks to the team.
Okay.
They're so
So I don't know, a story, that's kind of a story. It's gonna be hard to find the lie. So who thinks the lie is that Tim in 6th grade did a backflip on the jungle gym and broke his spine in 3 spots? 1.
I don't know.
All right. Who thinks number 2, that same year his older brother broke his back at a track and field event is a lie? Okay. So it looks like they don't think you're okay because the third one. So the third eyes okay thanks to OT. So it looks like the majority is saying that. So reveal the truth.
Well,
Yeah.
maybe you're like the same height. Maybe you're taller.
It's all true except I never had an OT, so the third one. I didn't have any. I just
Any
bought
therapy?
a back brace for
Wow.
not even that long. Month.
There was no like damage.
I'm just like a little bit shorter than I think because they were compression fractures.
Ah.
And not my hip. No. My older brother just had like a tiny fracture, but he has back pain like 20 years later. So.
Oh, wow.
Really?
But I was okay.
And your spinal cord, neither of your spinal cords were that's good.
The music, I was binge listening to Mount Erie. Has anyone listened to this? He's a songwriter who creates like really complex atmospheric music, but then his wife died of cancer and he just recorded these songs alone on his laptop.
Huh.
And it's like an education in grief. They're so awkward and beautiful and I recommend it.
Great.
I was a camp counselor for a long time. It's the best job I've ever had. So interest 4, experience 3, I'd say. And in the spring I'm at Cooper.
Okay. And was the camp, was that for typical
Yeah.
developing children or teens or
All kinds.
all ages and everybody? Uh-huh.
Yeah, from like age 7 through 60.
Uh-huh. Great. Well, thank you very much for sharing. Okay, so the questions we're going to look at today are looking at historical and theoretical perspectives of sensory integration theory and sensory processing disorders, and look a little bit at the neuro mechanisms underlying the theory and intervention as well. And then we're going to talk briefly about the evaluation process, but hopefully have some time for you guys to actually do some scoring on the assessments for Emma. So specifically, we're going to differentiate between sensory integration as a neurological process and frame of reference within the practice of OT. We're going to talk a little bit about the development of sensory integration across the lifespan, but we're only have a couple slides on that. Your book, the chapter that was assigned for this week, has about 4 pages, so it goes a lot more into detail, so be sure to look at that if you haven't. And then you'll be able to describe neurological structure and function that form the anatomical basis of SI in developing children, and then understanding a little bit about differentiating sensory, behavioral, emotion, and motor difficulties. For those of you who have had the opportunity to work with children who might have a sensory issue, have you found that it's not always easy to know if their behaviors are due to a behavior problem, a cognitive problem, or motor? And so I'm seeing heads nod. It's very difficult. And so Emma, I think, is a good example of that. If you got to look at her video already, but so we'll talk about that a bit. And then last is understanding the evaluation of sensory processing. So what's so funny?
Because of our classmate Emma, we looked a little confused. We're like, oh yeah, the case study.
Oh, the case study. Yes, yes. Not that Emma, the other Emma.
Yes.
Okay. So, have you, in your experiences as an OT student or before you were actually an OT, had you heard about sensory integration? And so, was it always positive? Was there ever any controversial kinds of things that came up? So do you want to, I'm seeing you nod.
Sure. So in undergrad, I learned about SI because I was at USC, which is where a lot of the SI theory comes from.
And that's where Jean Ayres, who we'll talk
Yeah.
about, yeah.
But then I was working with families in Southern California with children that have autism, and in talking to a lot of the parents of children with autism, they did not have the best things to say about SI and the
Okay.
evidence base and just differing opinions on it.
Okay, good, good story. So you're right, the Southern California is really the home of sensory integration. That's where Jean Ayres worked and started her first clinic and stuff. So anybody else had any other controversial kind of things or?
Well, I mean, just working with kids with sensory, I think, trying to change the behavior, thinking it's a behavior problem only has caused controversy more than the use of
Okay.
like those methods.
Techniques and
Yeah.
stuff. Okay. So I have found in my career, it's probably the most debated thing that OTs do. And for me, because I was in pediatrics, I mean, that's talked about. So if I worked with adults, I wouldn't probably say that. But as a pediatric therapist, I would probably say it was the most talked about and so, debated, right? So part of the reason is our own fault as OTs, because sensory integration is the name of a theory. So Jean Ayres developed the sensory integration theory. The chapter 2 on structure and function is out of this book. So we have the theory. Now this book is edited by Anita Bundy, Shelley Lane, and Liz Murray. And there was this is the second edition, so I'll talk about the first edition later on. I have a slide. But the theory of Jean Ayres is described in the first couple throughout this book. So we have a theory named that. We also have the sensory integration test. So we have an evaluation called sensory integration. And then we have sensory integration intervention. And so when we say SI, it involves a very lot of things. So the other thing I wanted you to think about is if you were talking to a neuroscientist and you said sensory integration, what do you think a neuroscientist would think about? So say that they don't really know OT. So I'm a neuroscientist too, so if you asked me, I'd have a different answer than say someone who does molecular, cellular type of neuroscience. So what do you think they would think of when they hear the term sensory integration? Any idea?
Think about the different types of receptors and how the peripheral nervous system brings that information to the brain, and then how the brain processes it and
Okay.
responds.
Okay.
Perhaps. I don't know.
Okay. Yes, and you're right. Does anybody else have any ideas? So there's in neuroscience, there's a multi-sensory integration kind of theory, and it has to do, it's at the cellular level, and so it's neurons that are in the primary sensory areas of the cortex, and generally some of the neurons spike to particular stimuli, so they fire based on stimuli. Well, there are some unique neurons in the brain that actually fire more intensely, say if they get both auditory and visual at the same time. And so they're multi-sensory types of neurons. And so sometimes neuroscientists will even be that specific where they're thinking about at the neuronal level, when things are integrated, they may fire more. So I got my PhD in neuroscience, and my instructors or my faculty and mentors were all at that kind of cellular level. And so trying to talk to them about why I was interested in learning more about the brain because of sensory integration, I learned firsthand that I had to be very careful and very specific on how I talked about it. And I think that's really given me, I've been able to more objectively look at it and think about how we talk about it. And I think a lot of therapists, all they hear are the OT version of sensory integration, and so they aren't able to describe it very meaningful to people who may not understand. So I think we have caused a lot of our own problem, and there are very many types of sensory-based approaches, and people call all of those sensory integration, and again, that's causing difficulty because those who really were diehards related to Jean Eyre's sensory integration, they get upset because other people call things they're doing sensory integration, and so we have caused a lot of our own problems, and by how we've named things and how we talk about them. So I guess I would say to learn as much as you can and be very careful in how you communicate about it. So how many of you had the chance to watch the video of the little boy? Okay, so were there things in the video that stand out to you? And if you haven't watched it, I really encourage you to watch it before next week, because one of the things that goes into some subtypes, and we'll be talking more about that, and I think it had some good illustrations about that. But so, what kinds of things came out for those of you who watched it? Anything that you'd like to share?
I love the way he described his sensory capacities in terms of like the volume of a cup, like how much he could process before it overflowed.
Okay.
That was a really nice visual.
Okay, good. Were there some other things that stood out to you?
He was able to articulate really well.
Okay, which
whether
is
he was reading or
right, which is not always the case, right?
Yeah.
So he was very articulate, and we'll talk about that again too when we talk about the inner drive, because a lot of our children are nonverbal or can't communicate or know what they're feeling and that kind of thing. So he is a little maybe on a continuum much more verbal and articulate than some of the kids we work with. Okay, were there other things that came out in the video? Okay, so be sure to watch it if you haven't. I think there's some good things in it. So making sense of sensory integration, SI is part of the OT theory and intervention, and SI is a factor in developing children that lead to changes in occupational performance. So when we get to the part where we're going to talk a little bit about development, you'll see how things emerge because the central nervous system is maturing, okay? And so an infant has different sensory integration capabilities than, say, a 7-year-old. And so that's partly what this is talking about, and how performance, occupational performance increases when the integration is more mature. And so the other thing about this is with development it can mature, but also with therapy it can mature. That's the thought, right? So it can either be through development or through intervention that this becomes more capable. And then OTs work from an occupation-based perspective, not from a single theory or model. Again, that probably is a bit of my bias, right? But coming from a holistic view, there are therapists that are very much just SI therapists, and again, I think that's been one of our problems as OTs, is that we're maybe not OT first, but we might be sensory integration first, and I think that that's where, well, you're not doing it like I'm doing it or the way it should be, rather than thinking about the occupation first. So I think that's been part of the issue. Now, I'm not saying that that's wrong or bad, it's just different, and I think we just need to recognize, and each of you will develop your own depending on what your experiences are and where you end up working. So this is Jean Eyre's, and so she originated sensory integration. Jean Eyre's one of her first books she wrote in 1972, and it was a book on learning disabilities. So in the 70s, autism was not even very well known then, much different than it is now. And learning disabilities was probably one of the largest diagnosed childhood neurodevelopmental disorders. And as you have maybe discovered or will discover, sensory issues are actually found in a lot of different disorders. So autism, just regular sensory processing, children with ADHD, children with learning disability. So it kind of goes across a lot of things, but she really emphasized the learning disability because that's what was known those days, and that's what was being treated and worked on in the public school or even in clinics. So her goal was to develop, she also got her advanced degrees in neuroscience, so she had a neuroscience background, and she wanted to really develop a theory to help describe and predict relationships amongst the brain and then sensory motor development and academic learning. And with learning disabilities, she really did emphasize in the schools and how the children would learn. And her definition of OT was the neurological process that organizes sensation from one's own body and from the environment and makes it possible to use the body effectively within the environment. So this was what she was describing in the late 60s and early 70s. So what does this sound like to you? Is there other theories that you've talked about last year or this year that make you think of?
Kind of makes me think of dynamic systems theory
'Kay.
because of the body and the environment, how those interact.
Okay, so the dynamical systems theory,
PEO.
PEO, okay, so those would be the two that I would say. And so she was really ahead of her game, right? Because those really didn't come about until later, but she was already thinking of those kinds of things. Okay? So, so in sensory integration, so the Southern California Sensory Integration Test, so it was the SCI, yeah, what?
SCSIT.
Yes. So when that was the first test that was developed by Jean Eyre, you had to be certified in order to give that. And so I took some certification courses, and they do a theories course and a intervention course and things on giving the test and that kind of thing. And in one of the courses I took, this diagram was used, and it really helped me understand that. The Southern California test has now been replaced by the SIPT, so the Sensory Integration and Praxis test, and I'll bring that down tomorrow so you'll be able to see it. And I know that there's another test that's actually going to be coming out, but I don't know when it's due out, that will probably replace the SIPT. The SIPT was started by Jean Eyre before she passed away, and then it was finished, and the psychometrics were done after she had passed away. But the Southern California test was developed solely by her. So this came from one of those courses, but basically what the thought is, and this was from Jean Eyre's original thinking, that the sensory information comes in and the integration occurs in the brain, the central nervous system processing, where sensory integration occurs. After it occurs, then you have the planning and the organization of behavior. So you've probably heard of motor planning and praxis and dyspraxia. So that's where this would occur, is having difficulty in the planning and organization. And then that leads to adaptive responses and learning, We'll talk quite a bit about adaptive responses today, but does anybody have an idea of what that means, adaptive responses? How would you describe that in your own words?
Is that like how your body responds to the stimulus? So like, if it's really bright out, you squint,
Okay,
maybe?
yeah.
Okay.
And if I throw you a ball,
You're
you're
gonna,
gonna
Yeah.
either catch it or put your hands up. So those would be adaptive responses. So it starts with a sensory stimulus, but then it's integrated and processed, and then you organize and think about it, and then you have a response to that, okay? And hopefully that it's a goal-directed response and it's successful.
could it also be like this, the sensory intake is like heat, and then you integrate it, and then your body like responds by sweating, or is that too much of a like? Yeah. You
Is
know
that
I mean?
what?
Too biological.
Yeah, I don't know. Like, is there a difference between your bodily reactions and then?
I would say that it's a little bit different, because, well, I was gonna say we don't have a lot of control over that, the homeostasis kind of
Yeah.
responses. And Jean Eyre's thought was that when she talked about this is that we do have control over that and it can change. But some people, I mean, those medical type of conditions, so when people can't sweat, there's not a lot we can do about that, right?
Okay.
So it's more, so it's not more of those automatic, even though some of our responses are thought to be automatic, you can adapt those and change them, okay? So that's a good question. And then that leads to feedback. So what do you think feedback means in this sense, in this case?
How the environment or the stimulus is kind of responding to what you're doing, maybe.
Okay, so the stimulus and the environment,
So like where you're getting the information from, you organize it, you plan behavior, you do the behavior, and then the result of your behavior
Okay.
is kind of like how everything is responding.
okay, right. So what the results were. So if it was successful, you'll get different feedback than if it wasn't. So like the example of tossing a ball,
Yeah.
if you didn't successfully catch it and it hit you in your face,
Right.
your feedback would be a lot different than if you actually caught it.
Right.
Okay? So, and the feedback can also be verbal, right? So someone can give you feedback about it. So it doesn't have to be internal, but it can be internal. And then that then gives us feedback about the next time or the next thing that happens, and so it's a cycle. So that kind of describes what Jean Eyre's means by sensory integration, the whole process. All right, so this figure is actually in the first chapter in this book, and we'll be putting this chapter up, the first chapter up for you next week. So can you understand that chart? Is it a little complicated? Okay, well let me show you another one that's on the page before this. So it's, whoops, sorry, I don't know what just happened, but I'll fix it. I pushed a button on this scanner and it advanced the slides. I never knew that would happen. I guess I've never done that before. Okay. So I got a lot of feedback on that one.
Oh, yeah.
So this figure is on page 6, and And the one that I showed in the slide is on page 7. And this chapter we'll have up for you next week. So in this figure, so if you think about this figure with sensory integration or sensory dysfunction or sensory function, we basically have two different types. We have dyspraxia, so this is dysfunction, or poor modification, okay? So if you think about this simple figure, it'll help you understand.
Oh, goodness.
It'll help you understand this more complex figure. Right there. So you have SI at the top, and then you have sensory modulation here, or poor modulation, and on the other side you have dyspraxia. So if you think of that simple figure first, then I think it'll help you understand this one. Before we go into details, did you see who drew this photo, or this figure?
Oh, David Green.
So
Yeah.
David Green. So I always like to tell students that because it makes you feel a little more part of this whole thing. So the first edition of this book was written by Ann Fisher and Anita Bundy. So you know that Anita Bundy was here like probably 17 years ago now. So when I came in 2000, she and I were here together. She taught P's, and then I took it over after she left. And then she went to Sydney, and then she came back. And when she was here before, Ann Fisher and her actually wrote the first edition to this book, and they were working here with David, and they asked David to draw this figure. And that one then was carried into the second edition as well. And they're working on a third edition, and I haven't seen it, so I don't know if it still has David's figure in it or not. But I just thought that that was kind of cool. All right, so let's start with dyspraxia. So what the middle is showing you the sensory systems in the central nervous system, and it's showing you which ones of these lead to modulation issues and which lead to more of the dyspraxia issues. So there are two disorders, according to Ayers, related to dyspraxia. Bilateral integration and sequencing problems, so that's BIS. So bilateral integration and sequencing. And then the second one is somatodyspraxia. I would say that bilateral integration and sequencing difficulties are milder and less involved than somatodyspraxia. So a child who has somatodyspraxia will be more involved with it. A lot of the children, if you see children with sensory processing issues or sensory integration issues walking down the street, it's hard to tell that they really have trouble until they get that challenge they just can't deal with. Whereas somatodyspraxia, it's going to be more obvious, okay? One of the differences, you'll notice that postural feeds in more to the BIS, and discrimination feeds into more of the somatodyspraxia. So when there are discrimination difficulties, like not being able to sterignosis and those kinds of things, but the other thing that becomes very difficult with somatodyspraxia is body schema, knowing where your body ends and the next person's bodies begins. So there's a lot of bumping into things or just not really understanding body schema. And there's also, from my experience, a lot more lower tone involved with somatodyspraxia. You may see low tone with BIS, but it's more severe, I would say, with somatodyspraxia. okay?
My question.
Yeah.
If these aren't addressed in early intervention or really just when they're children, do they progress throughout your lifespan, and do they look different when you're older?
So it's like, I would say it's very much like ADHD. So some people are saying, oh, people with ADHD, they'll grow out of it. But we're finding, and research is showing, that that's not the case. And I would say that with sensory integration issues, that is true, that it remains with you. But what happens is, as adults, we compensate for a lot of things, and so it won't be as obvious.
Well, it's something that I've heard therapists talk about is that everyone has some sensory processing kind of issues, and with being like an SI therapist, it's important to know what your own issues are, and then how to like utilize those when you're working with a child who also has like a sensory concern.
And I agree with that. It's not specific to SI. We all have strengths and weaknesses, you know, but because sensory, motor, and interacting with the environment is such, everything we do is that. So if you have weaknesses, it'll come out in those areas too. So yeah, good point. Any other questions on this side? Okay, so some of the symptoms will be clumsiness, clowning, avoidance of motor behavior, or exaggerated or diminished force. I don't know if any of you have had the opportunity, like in a classroom, to see children who just jam the pencil onto the paper and the lead breaks and all of that. So that's an example of force. But even just in the way they interact with people, you know, they may not understand. So an older brother may push a baby sister, but not really meaning to push them, but not understanding the force. So that's what that exaggerated or diminished force means. Then on the modulation side, we have aversive response. So you're aversive to sensory stimuli. You'll have gravitational insecurity. Does anybody know what that means? Or have an example? Do you have that?
Yeah.
So what are some symptoms?
You don't like to, like roller coasters are like a nightmare. You don't like to have your feet necessarily like up
Off the ground.
ground.
Okay.
How is that, like, is it related to like motion sickness, or is it something separate, or like?
It's not related to motion sickness.
Okay.
It's what?
It's not related to motion sickness.
Yeah.
Okay.
It's
It might be
similar
for some.
in that they all involve the vestibular system,
Okay.
but the symptoms are different.
Okay.
Yeah. So remember that big orange ball we had out the last couple of weeks in lab? So one of the ways to really discover about a gravitational insecurity is if the ball was in front of me and I have the child on the floor facing me, so the ball is to their back, I pick them up and put them on the ball like this. I have had young children begin screaming and crying. Okay, I didn't do it on purpose. I mean, that was not the intent at all. But I learned that is one of the best tests for gravitational insecurity, because they can't see what's happening and their feet are coming off of the ground and they're being moved. And so that's what really elicits those kinds of feelings. And therefore, they probably avoid a lot of different things is because of these, okay? And then defensiveness to tactile, auditory, or visual stimuli. And so they're very sensitive to these different sensory stimuli. And then there's under-responsiveness. So under-responsiveness means that, so for example, sometimes self-injurious behavior is because of unresponsiveness. because just do things over and over, like bang their head, because they're just trying to get something in. Now, that's not the only explanation for self-injurious behavior, but it can contribute to it. So sometimes it's difficult to decipher between aversive gravitational insecurity and defensiveness, because in these cases you may avoid certain things, but if you're unresponsive, you also may not be doing things. So you really have to think about what the stimulus is and what the responses are. Unresponsiveness sometimes leads to sensory seeking. So like they'll bang into things, or they'll get in the ball bath over and over, or do those different kinds of things. Okay? Any questions about this? All right. I think what we'll do is take a break, 10-minute break, and come back and finish up with this theory part. I have a couple of announcements to start this second part with. So how many of you are in the afternoon lab?
It wasn't
How many of you are in the afternoon lab tomorrow? Okay, so, and I think some of the people who are missing, so if you have friends who aren't here, be sure to remember tomorrow we're going to start at 12:30 and go 12:30 to like, so it'd be about 2:20 we'll be done. The reason is because there can be no cars on campus after 3 o'clock. And so I'm doing it for you as well as for me. So that'll allow us time to get cleaned up and have everybody out of here. So if you know there's some other people who aren't here today, you might want to remind them. And if you forget and you come at 1, we'll be started, but at least you'll get to have some of it. So tomorrow afternoon lab will start at 12:30 instead of 1. The other 2 labs will be the same, 8 and 10, so nothing will change on those. And then the other the other announcement is Beth sent out the final schedule, and you saw that OT 632 was listed all day Tuesday, and nobody knew what was with. So Andy and I have talked, and we're going to have everybody come at 9 on Tuesday, and we'll have room 103 and 101. So we'll be from 9, I think it's like 2 hours, probably. I don't think it'll be even 2 hours, but we'll start at 9. So I think they'll block out 9 to 11 for us, okay? And I don't think Beth is going to send out anything else, so we'll just keep you posted as we know more about that, okay? So if you're making plans for travel or whatever, we will be done by noon on Tuesday, okay? All right, so back to SI, bless you. Back to SI and theories in general. So why do we have theories? How do theories help us as therapists?
Try to understand things.
Okay, so tell me a little, you're right. So tell me a little bit more about that. So theories help us understand things.
They guide practice
They guide practice. How do they guide practice?
by giving you a model to follow.
So models, they help us understand things by models or describing things. Okay? What else do theories do?
Guide research. They guide research too.
Okay, they can guide research and help with evidence-based practice. Okay?
They could also help provide consistency within a field, like if everyone kind of has underlying
Okay.
knowledge of a theory, that can make practice more consistent.
Okay, good. And when we think about guiding, so there's one other piece of theory I'm trying to get you to think about. So in guiding therapy, so say we we do some assessments and some observation, and we know that maybe we have an idea maybe that a child has difficulty with gravity. Let's just use that example because we've talked about that. So if we know that, what based on SI theory, what might we know from that? I mean, so what does the theory help us do? What?
Predict behavior.
Predict, okay? So it gives us predictions about if this, then this, okay? So, sensory integration theory is no different. It does all of those things for us. So it helps explain why individuals behave like they do. So it gives us information in that way. It helps us plan intervention to improve dysfunctions, and it helps us predict how behavior will change, or help us predict maybe what the next step is, and those kinds of things. So that's how how this theory helps us in intervention. There are 5 assumptions associated with with Jean Ayres, SI theory. The central nervous system is plastic. And that's true not even just for SI. What if the nervous system was not plastic? How would that change us as OTs? What would be different with our interventions if we knew that the brain was not plastic?
We could really only do restoration.
Okay, so we would mainly only do compensation and adaptation, right? It would be hard to do remediation and restoration unless the restoration is done by compensating, okay? But we know that's not the truth, that we know that the brain is plastic. So one of the main assumptions of SI is if we do these therapies, it may quite possibly change the way the brain processes information, okay? So that's one of the assumptions. Another is that sensory integration develops over time. So if I see behaviors, and I'll use a little girl as an example. This morning I used a little boy. But say a little 2-year-old girl. What do they do if you have them like last week on Friday with our lab set up, and you put a little 2-year-old in that mix? What would they be doing? Most likely.
Playing around.
They'd be running around like crazy and trying this and trying that and trying the other. Now, if we put 15-year-old in that same setting, would it be different?
Yes.
Probably, okay? If I hadn't used that example of what we had set up, I was going to say a 7-year-old, but a 7-year-old girl may do the same thing, right? But it'll change, and we expect something very different from an infant, a 2-year-old, a 3-year-old, a 7-year-old, because the central nervous system matures over that time. Brain functions as an integrated whole. When we were talking about reflexes, you might remember we talked about the hierarchical approach and the heterarchical approach to reflexes. And the hierarchical approach is that the cerebral cortex controls all the rest of the brain and influences it. The heterarchical approach is really that they all work together, and it's not just a top-down approach. And so Jean Ayres thought of the brain more not necessarily as a hierarchical approach, but that it was all integrated together. Adaptive interactions or adaptive responses are critical to sensory integration, and like I said, we'll talk more about adaptive interactions about that. And then the last one is that people have an inner drive, children and adults, have an inner drive to develop sensory integration through participation in sensory motor activity. So if you think about that 2-year-old running around in the lab last Friday, they just do that. They have an inner drive. I had a good question this morning. What happens if you work with a child who doesn't have that inner drive? Have any of you seen a child like that? Or maybe even an adult who didn't have that inner drive? So what do you do? What do you do when you don't see that intrinsic inner drive? And the question came, and I said, you know, that's probably one of the biggest challenges I had when I was a full-time therapist, is when you find those clients or those children or adults that just don't have that inner drive. So what do you do in that case? What are some ideas? Yeah, Meg.
So a big one would be motivational interviewing. Just saying, it's a tactic that you could use.
Okay.
One of the biggest things that they tell you to do is to not tell them what to do.
Okay.
And let them guide the therapy session.
Okay. So that's a great idea. So finding out what they want, right? And that's what that motivational interview is like, right? Is just trying to find out what motivates them. So making it a little more difficult for children is that, you know, up to age 5, it's going to be hard for that. I mean, they can make choices and stuff. And then we have children who are nonverbal. And then those kinds of things become more difficult. But if they're verbal and they can really interact in that way, that would be the first go-to, is to do that.
Sorry, another one, is that I was talking to a professor in the psychology department about motivation, and she's saying that the behaviors that people have, like a lack of motivation, that's a behavior, and if you try to understand why they're feeling unmotivated, that's a huge piece. So like, okay, it's important to understand what motivates you, but like, why are you acting this way? Like trying to like take that attitude and understand where it's coming from, that could be a huge benefit towards helping them participate.
And with adolescents and adults, I think that's easier than children, right? But it's a good point. And even with children, you can do that to a certain extent, okay? Is really figuring out why they aren't motivated, okay? So what are some other approaches? What are some other things? What would you do? What would you do if you were in this situation and the child just wasn't doing, it felt like that child wouldn't do anything? I mean, you gave an example.
Yeah, I think like building their self-efficacy in another somewhat related domain helps translate that at a later date to the skill that you're trying to attack or develop.
Okay. So how do you build self-efficacy in a child?
Let them win it connect approach.
Strengths-based, and what did you say?
Let them win it connect for.
Let them win, but you can't let them know you're letting them win. But yes, strengths-based, what is it that they can do? Doing the just right challenge, right? Is letting them be successful, but not being insulting, right? If it's too easy and they can do it, that doesn't build their self-efficacy. So giving them just the right challenge, okay? What are some other things that you could do? Modeling. So modeling what in this case?
If there's some sort of activity that you like them to participate in that they don't have a drive for, if you're interacting with the materials and having fun with it that way, instead of them just being like, there's this thing and I don't know what to do with it, and it's like, well.
Okay. And modeling exuberance, right? So you don't say, oh, come on over here, let's have some fun and let's do this, right? That's not going to motivate them, right? So modeling and being exuberant or joyful, even if you're not, right? Even if you're not. So like someone said, you know, with it being nice outside, you know, I can't just stand up here and be depressed because, you know, 7 people didn't show up today, right? So I have to be excited and enthused even with that, right? But I'm okay. Yes.
Oh, I just totally lost it because that was funny. Wow, yeah, it's totally gone.
It'll come back to you.
Katie, did you have one?
Oh, I had one. I feel do you want to try this? And kind
Right.
of like getting it to more
Okay.
of what you're trying to go for.
So you said something, you said a lot of things important, but one really important thing we hadn't addressed was that trust and building that rapport, and so, yes, and figuring out how to do that. And it may not always be exuberance, right? And so coming to them and meeting them where they are. Okay, good. Go ahead.
I had two, maybe asking the parents what they're
Okay.
motivated with at home,
Yeah.
what makes them excited. And then just maybe introducing various things, trial and error,
Okay.
but after you build trust.
Okay, and so the example I gave, this scenario, that switch toy with the bubbles, so something novel or new, those kind of introducing new things. Yes.
What do you think about like rewards and positive reinforcement? Because I feel like if it's overused, it won't be effective, and also it might make them purely extrinsically motivated, which
Right.
is, you don't want that.
Yeah.
So
I use behavior modification as a therapist. And most of what we do is really doing that through modeling or whatever. So I think, setting timers, saying we're gonna do this for, 2 minutes and then you can do that, or, giving, and depending on what the rewards are, but making sure it's culturally appropriate or the family friendly or whatever, I think that there's nothing wrong with that, to doing it to a certain extent. Yeah. Okay. So the other thing, asking the parents what they do at home, but if you're like in the school and you may not have access to the parents, is observing in other areas. Look in the lunchroom, look in, on the playground, look in the gym. Is that child always unmotivated, or are there things that are motivating, or talk to team members? So I think that that's a really, generally people have the inner drive, but the most challenge I think we have as a therapist, both with children and adults, is when they're not motivated. So working on trying to find that and bring out that inner drive. So neurobiological concepts, using sensation and experience to organize a successful goal-directed action in the environment. So that describes what adaptive response is. It allows a child to successfully meet a challenge in the environment, so the just right challenge. And making an adaptive response, the child is an active doer. So the child is doing something, and that's a part of the adaptive response. It's not being a passive recipient. There's one exception to that I'll show you on the next slide, which is the very first level of adaptive responses. There may be some passivity, but generally as an active doer. So have you heard of the brushing that is sometimes used in sensory-based? So basically, and I have not been trained, now Lisa Fife uses it, so you've seen her use it? Yeah. I tended not to use it, but it's taking a particular brush and rubbing in a particular direction, and there's all the procedures you're supposed to do with that. To me, that's an example of a passive activity. And according to AIRS related to adaptive responses, that would not really fit under the AIRS sensory integration approach. But it is a sensory-based approach, and it doesn't mean it's wrong or not good. I just didn't use it because I never found a reason to use it. I'll say that. So the other thing is to look at evidence-based practice, and to look at evidence, and is there evidence? And I think brushing, they're doing more research, but I don't think that I have read an article yet that shows what difference it makes and how, kind of thing. So that's just an example of a type of sensory processing or sensory-based interventions that would not be classified as AIRS sensory integration intervention. So levels of adaptive responses. So as I said, this very first one is tolerating passive stimuli during an activity. So the child may be doing something, but you're passively maybe applying some kind of stimulation. And the thought is this is the very first level. And that could be how the brushing could be used. I don't know how long a therapist may use it. I don't know if Lisa's talked about.
I mean, the one child that we used brushing for in the classroom, they just do it for diaper changes, like around 2 to 3 hours is typically when they do it. And for her, she has a larger sensory bucket than some other people, and she likes a little bit more stimulation. So if she gets it through the brushing, she might not be going up to her classmates and like hugging and squeezing as much, but it's about every 2 to 3 hours.
So cute.
Okay, so that's so I'm just trying to think of even just holding. So a child who doesn't tolerate tactile, even just holding them or hugging them could be an example of tolerating passive stimulus. The examples I'm going to use for the rest of these will be moving, just because they're the easiest to talk about and think about. But holding and staying put. So an example of that is the platform swing we had over here. If you were sitting on it cross-legged and you were holding the ropes, and then the therapist just passively moves. Excuse me. Passively moves the swing. That would be an example of holding and staying put. Sorry, I ate a granola bar during break, and I think there's a little piece of peanut stuck in my throat. The other example, holding and staying put, that I like to use is there's a swing that has a bolster in the middle, and it's hung by the bolster. So think of a child sitting on the platform swing and wrapped around like a monkey, holding on to that, and then passively moving would be an example of holding and staying put. Alternating contraction and reaction, relaxation of muscles. So I think of that as like push-pull. So an example of that is in the net swing. If you were laying on your stomach and I took a hoop, the hula hoop, and held it out and had the child hold on to that, and then pull and push to make them go. And you could do the same thing like on the platform swing we had over here with the rope, is give them one end of a rope and have them push and pull that to make them go. That would be alternating. Moving independently in a familiar way. So one of the things, so that could be, well, moving in a, well, I'm not sure how familiar that was, but if you're laying prone on the swing and you were pulling your arms to make yourself go, you were moving your arms along. That may not be real familiar to adults because we don't do that often, but that kind of thing. So just moving, doing things in a familiar way. And then moving independently in an unfamiliar way. And what I would often use for this is putting up an obstacle course and doing different things. So they may have to crawl under the bolster swing or crawl through a tunnel, a cloth tunnel, those kinds of things. And so really just creating situations that they may not have seen again. And that would be moving independently in unfamiliar ways. And then the last one is completing a complicated activity during requiring unfamiliar, difficult timing, or multiple adaptations. So this example of skating, A lot of sports would be like that. So now if you practice a lot, it wouldn't be unfamiliar, but those kinds of activities would be. So that's how you grade for sensory integration, is you basically move through those things with the sensory stimulation, whether it's a vestibular stimulation or tactile or whatever. So we already talked about neuroplasticity. The nervous system changes to response to ongoing stimuli. And then if you're in a meaningful and active mode, the brain is going to, it's going to produce more permanent changes because it becomes more integrated into the processing. Feedback. We've talked about feedback and how that occurs in that cycle that we talked about. And these are the examples we gave. What is a feed forward? Think of an activity where you have to use feed forward. So feed forward. What does that mean?
Imaging, like, playing something through your head before you do it.
Okay. So
What would that be called?
that's kind of rehearsing.
Okay.
Mm-hmm.
Would it be
Sounds
like
like
you
mental imagery.
have to do
Yeah.
it and then get feedback after you've tried it?
So you have to do it. That's still feedback.
Okay.
That's not feed forward.
Is it like, say you're lifting weights and you're working out and you're gonna do 10 pounds more the next week, but you've never lifted 10 pounds more, but you brace yourself a
Okay.
little bit more in preparation of lifting that heavier
Okay.
weight?
That could be an example that you're anticipating what that will be. Think about sports for feed forward.
So would it be like when you're learning how to kick a soccer ball and you know I need to put my left foot to the left side of the ball, so you're kind of like consciously putting your foot there to swing forward with your other foot?
Okay.
That was confusing, I'm sorry.
So the example I was going to use is like a quarterback. Okay. So a quarterback, say it's a passing play, and there's a couple receivers. So the quarterback has to look to see which one might be open. Then they have to anticipate, okay, now he's going to be running that way. He will get there. I need to throw the ball now to get there when he gets there. So that's the feed forward. It's really anticipating what the movement has to be based on what's going on in the environment. And I would say that the receiver also has to do a little bit of that because they have to be watching the quarterback as well. And if the quarterback gets caught up or something, they have to change their trajectory, or they have to run faster or slower to get there. So that's what feed forward is. And next week we will talk a little bit more about that, but basically another way to grade activities and sensory integration is to go with feedback first and then feed forward. And people with the bilateral integration sequencing, remember that was the dyspraxia that was at the top on this column in that complicated chart, is really getting them to this feed forward stage. So a lot of times they function only in feedback, and then you work towards getting the feed forward.
So is feedback typically a pretty controlled environment, whereas the feed forward there's a lot of more like dynamic changes?
And usually you have more moving objects or parts of environment.
Okay.
And the more things that are moving, the more feed forward it has to become.
Okay.
Feedback is everything is stable. The easiest activity is when the person is stable and the object is stable. And then as things start moving, it gets into more feed forward. Okay, good question. Okay, so we talked about the innate drive or desire. Interactions with the environment promote adaptive responses, and they occur also at the limbic system. So we'll talk about that a little bit. So it's not just sensory level, but there's some limbic system level for inner drive as well. So what we're going to do next is talk briefly about the lifespan. As I said, I think we only have like 2 or 3 slides on that, and there's a lot more in the book on this. So development of sensory integration. So actually, sensory response to sensory stimulus occurs as early as 5.5 weeks gestation. So the movement or the heartbeat, those kinds of things, in utero, the fetus will begin to respond to sensory stimuli as early as 5 weeks gestation. And then touch, smell, and movement are the primary importance to the newborn. It's not that auditory and other things are not, but based on the maturation of the systems, that touch, smell, and movement will be the most important to a newborn. Tactile input really helps establish that trust and those rapport. And I know that in working with children, I actually use tactile a lot, possibly in developing the rapport. And I'd never thought of that before. But I think having that tactile input and that communication through touching and those kinds of things can really help establish that rapport. And then feeding is a reflection of an essential sensory integration skill. So it involves the sensory, internal, possibly hunger, recognizing that, but then also the sensation of nipples and those kinds of things for the goal-directed behavior of eating. And then the vestibular input is calming to newborns. So how many of you have babysat or worked with an infant, and if they're crying, what do you do? Okay, so I'm seeing this and I'm seeing this. I would often, do this kind of thing for a child who's very difficult. Some people put them in the car and drive them around. So the slow movements and rhythmic movements are really calming to infants.
Can I ask a question?
Yeah.
For the tactile input, does that vary based on age? Like, were you working with like newborns and young, or like, are you even talking into?
I would
later
say
childhood?
early elementary.
Okay.
Yeah, and it might be as much. So I even use it in collecting EEG. So if we have a child with autism coming in, I often, again, I'm careful about respecting everything. But if they seem anxious, do you mind if I put my hand on you? Is often, again, a deep pressure kind of touch, often, and then they'll look at you and you can get that eye contact, and it often works really good for calming and developing a connection.
Thank you.
Yeah.
I was just like, what does that look like?
So that's how I use it. Sometimes if a child is sitting next to me and they're getting nervous or having trouble, even just putting a hand on their leg to calm them or that kind of thing. But again, it's more of a deep pressure. It's not a light touch is what I would use. And we'll talk about that a little bit as we get into the tactile system. So as far as development, bless you, the child becomes more independent with exploring their environment. So again, the self-efficacy, the more they do it, the more comfortable they get, and then the more they explore. And then movements become more precise and allowing for more sophistication in manipulating objects. So we saw that in fine motor as well, right? They just get more confident in what they can do. Roles and expectation and typical childhood activities place more demand on the child, thus widening the gap when dysfunction occurs. So parents start giving chores to the children and those kinds of things. So the more demands. It's about second grade where I have noticed from my experience in working in the schools, kids with disabilities do pretty good until about second or third grade. but then the demands become a lot harder. They have more homework, they have more kinds of things, so they usually do pretty well up to that point, but then it becomes more difficult. Now, Ayers found that children, typical children, had fairly fully mature SI systems related to function by 7 years. I would say that research has shown that this is not necessarily true, that I think the systems continue to develop. But she thought, and some of the readings you may see, that maybe after 7, that sensory integration isn't needed. But I would say that I'm not sure that there is evidence to support that I think it continues. Okay? All right, so we're going to get into the neurological structure. I'm going to do a couple of, a little bit. We'll take a break, and then we'll finish this up with the questions from your study guide. So we'll just go through those, and I'll give you the answers and see if you have questions. So that's what the next part will be. So we'll start that. I'll do a little bit, and we'll take a break. So according to Jean Ayers, there were, she thought that the 3 primary sites in SI or sensory issues were vestibular, proprioceptive, and tactile. Okay? So those are the ones that SI, Ayers SI, sensory integration, really emphasizes, is vestibular system, proprioception, and tactile. And we're going to go over receptors, the vestibular system, somatosensory system, and in the somatosensory system, we're going to talk about tactile and proprioception and how those are related but different. And I think that's a really cute picture. That's actually one that Lisa Fife found that I really like. Okay, I think let's take a break. I have something in my throat again. So let's take a break, 10 minutes, and then we'll finish up this section.
Yeah. I wish that I was in on this wavelength so badly.
I have all
So let's start with receptors. So we have some classifications of receptors, and the next slide has the cartoon or the image that will help us see these more specifically. But for receptors, we have exteroceptors, which are found in the skin. And you can see that we have some that are fast adapting and some that are slow adapting. So what is the difference between those two?
Fast adapting ones like sense the beginning and the ending of a stimulus, but not the continuous stimulus.
Okay.
A slow adapting one.
Okay, very good. Excellent. So what's an example? Can you think of an example of of fast adapting?
Like a pinprick or a light touch.
A what?
Like a pinprick or a light touch.
Pinprick could be the other, but light touch could be. So what we think of often to help understand this concept is your clothes. Okay? So until I said that, you probably didn't even notice your clothes were touching your arms and that kind of thing. And so once we put them on, we feel it when we put them on, and then we forget about it. And then when we take it off, we notice. So that's a good example of a fast adapting. So we feel it when the stimulus is applied, and then when it's removed. Okay? Now, fast adapting is the free nerve ending is a good example, which pick up pain. And so like heat, so your hand is on the stove, you want it to go until, you want that firing until the stimulus is removed, right? And so pain, heat, those kinds of things are slow adapting. So the receptor continues to fire as long as it's being stimulated. And then proprioceptors, these are found in our tendons and our muscles. So they're found in soft tissue. So in the next slide here, which is the photo, the image, so this shows the free endings have to do with pain, heat, and cold, and those are the ones that are generally slow adapting, or yes, slow adapting. Merkel discs are sitting right here. They have to do with touch. Krauss in bulbs having to do with touch. Root hairs, so down here at the bottom of the follicle of the hair is a touch, and then Meissner corpuscles are up here, touch, and then Pacinian corpuscles and Ruffini endings are pressure. So what's the difference between touch and pressure? And so we talked about that a little bit.
Well, it's deeper, right?
Okay, so the pressure is the deeper. So what the example is really pressing in, so it goes further into the epidermis area. Okay, so it gets down further, whereas except for the hair, the root hair, but the hair is up here, right? So the stimulus actually occurs up here, but the receptor is down here. But the toucher tend to be closer to the skin, and the deep pressure is lower. Now, what's the difference between deep pressure and proprioception? So let me ask you this. A weighted vest, what does that get at?
Deep pressure.
Deep pressure, okay? Now some people sometimes confuse that with proprioception, but proprioception has to do with muscles or tendons, so it's usually to do with position or movement, okay? If someone has tactile defensiveness, from my experience, touch is much worse than deep pressure, okay? So if I'm dealing with someone with tactile hypersensitivity to touch, I will use more deep pressure with them. I tend to use more deep pressure, period, than light touch. And probably the worst is the hair. So just rubbing right over your hair on your arm, if you do that, you really can feel that. And it's really, if you think of someone who's tactily defensive, it really is probably the most annoying of them. Okay? Any questions about proprioception or touch? Okay? Vestibular system. So where is the vestibular system? In the inner ear. And we have two sensory receptor systems for vestibular. We have the otoliths and we have the semicircular canals. The otoliths are slow linear movement, and they facilitate tonic posture. And I think there was an earlier, so under proprioceptions we had tonic and phasic as well. Tonic tends to mean more the core stability, and it's for stability more than movement. Whereas phasic is more, it's faster and has to do more with movement. So that's the same with otoliths. Otoliths are more tonic, whereas the semicircular canals are more phasic. So so of the, well, so these are some examples of equipment. So last week in lab we had 1 point, the net swing and the platform swing over here that were 1 point. And we had the big bolster there and the platform here that were 2 point. So otoliths are usually stimulated more from 2 point, okay? You could stimulate otoliths from 1 point if you do a linear movement, okay? But those of you who were in the net swing, if you went far enough, you had those arches. If your 1 point gets into arches, you will be stimulating the semicircular canals, okay? And we'll talk a little more about that in the next slide, okay? So the responses to the semicircular canals is phasic postural responses like equilibrium. So like, so equilibrium is kind of a movement like that, you know, it's more of a full body rather than just stability, okay? All right, so more specifically to the vestibular system, we'll talk about the semicircular canals first, which are these 3 structures here in the vestibular system. And so each of these, there's 3 of them because they're in different planes. And so depending on where your head is in space when you're getting the stimulation, it will stimulate one or another of these. They're stimulated by rotation and angular movement, so that was why when you get the arch, you get the angular. Another way to think of angular is when so when a plane is taking off, they're on the runway, and then all of a sudden they lift up, and it's that angular that will stimulate the semicircular canals. Whereas on the runway, that would be the otoliths, all right? And then once they get up to high altitude, then they level off again. But it's in that ascending and descending that would stimulate the semicircular canals. So the receptors for the semicircular canals, they're in at the very end of the canals, and basically what it is, it's the cupula is like a sac filled with gel, okay? And there's fluid in these. So the fluid will move when the movement occurs, and that will make the sac go in one direction, and it stimulates the hair cells down here, which then go up the nerve, okay? So how many of you have seen an LP record player? Okay, so I want you to think about if I put a glass of water on the record player and it's going, let me ask you this. When will the water in the cup slosh? Does it slosh as it's going around? When you start it or stop it, okay? That's the same thing with this cupula, okay? If you're going just going around and around and around, it's not going to change that gel, okay? That cupula is not going to move. So if you want to stimulate, if you want to get phasic and equilibrium responses, you have to change the speed. Okay, just going around and around will not stimulate. So you need to start, stop, accelerate, decelerate, change directions, and all of that. So just going around in circles isn't going to is not going to set off the receptor. Okay, the otoliths, there are 2 of them, the uticral and the saccule, and they look something like this, and they respond to linear movement, up and down, straight ahead, so up and down or back and forth, and gravity. So gravitational insecurity would be related to the otoliths in this case. And what the otoliths, the response is tonic, maintained, or stability. And these are the receptors for it. And these have like little crystals on top, and if the and they're in a fluid, and or gel, and if the gel moves, it'll move the crystal, and the hair cells will fire or will move, and it'll make the receptor fire. Okay. So I thought I had another something else related to the otoliths. Let me see if it's in my notes here. I will look it up. I think one of these is more related to gravity than the other, and so I'll look that up. I don't see that in my. Do you see that?
Oh, it just says in gravity.
Right. Yeah.
Okay.
So I will look that up. So any questions on the vestibular system?
I have a question.
Yeah.
If you're stuck in an avalanche,
Uh-huh.
and you're all tumbled up, and then you're under snow, do you know which way is up? Can you tell? There's a lot going on there, but I'm just curious.
Have you ever gotten like knocked down by a really bad wave in the ocean and you don't know which way is up?
Oh,
That's
yeah.
that's really
It's like
scary.
In a
It's
wave.
like a temporary moment.
In a wave. Yeah. I think that because water and snow distort gravity, and so
That's what I was curious about. I was initially thinking about a pool.
right. So because gravity is distorted, I've heard, I have not been caught in an avalanche, but thank goodness, but I've heard that's the problem, is you don't know which way is up.
Okay. I see.
That can happen, so that's very frightening, yes.
Okay.
Yeah. And you have no visual.
Right.
Yes,
Yeah.
yeah,
Okay.
okay. So your otoliths are probably not working really well with,
Yeah.
to tell you where gravity is. And your semicircular canals have probably been stimulated a lot.
Yeah.
So your system is all confused. Okay, I don't want to go into the tracks very much. They're listed here. I want you to think about them now. We talked about them related more to facilitation and handling and fine motor. And now I just want you to think about them in relation to sensory integration. So a couple of the things, the reticulospinal tract facilitates axial and proximal limb muscles. So like if you were to ride a scooter board down a ramp, that would stimulate and you would get more extension and those kinds of things. And the vestibular tract also does that. So I want you to think about these tracks now when you're doing intervention. You know, how is it working up or working down through the tracks? Okay, motor learning. So you know, thinking about dyspraxia and those kinds of things, and where some of those where some of the difficulties are really coming from, or facilitators in intervention. We've talked about proprioception a little bit, movement against resistance, including gravity. It facilitates postural responses, body schema, and force. So the child who doesn't understand force, you'd want to work on proprioception. Body schema. Remember I talked about somatodyspraxia, having a lot of difficulty with body schema. They also have force problems. So people with somatodyspraxia, we're probably going to use a lot of proprioceptive type of interventions like tug of war, just that push-pull, those kinds of activities to get the proprioceptors working. These give examples of how you can work on proprioception. So one thing to think about related to sensory integration is movement is going to really facilitate the vestibular system, and positioning is the proprioception system. They work together, but they are really separate. So you need to think about what your intervention is doing and what you're emphasizing. Okay? Sensory motor tracts, somatosensory tracts. So again, we've covered these before, and the information is the same, but just thinking about discriminatory touch, proprioceptive, touch pressure. So much of what we do is through the DCML. Pain and temperature and those kinds of things are going to come through the AL, and then your facial actually does all three of them, right? Pain, temperature, and light touch and pressure. Okay? All right. So if you have your questions, we're going to walk through these, and I'll give you the answers to them. So these were on your study guide. So question 1, which of the following is not true about sensory processing? What?
I couldn't find this one actually. Like
Anybody?
D. D as in dog.
D is in dog. Okay. Anybody want to pick any others? Okay. The answer is D. Yay. That brave soul, you got it right. Very good. Okay. So this is not true. So sensory processing actually gets more specific as it progresses through the central nervous system. So like in the brainstem, it's not very specific, and then as everything gets integrated and it gets up to higher levels, it's more specific. Sensory processing influences motor output through cognitive processing and automatic states. And sensory processing is cyclic influence on motor output based on the feedback loop. So kind of that first picture that had the feedback loops and stuff. Okay? All right, number 2. Which of the following is not true about sensory receptors? Okay? Do I hear anything more than C? C is the answer. Okay? A weak stimulus will activate the same number of receptors, and that's not true. More intense does more receptors than a weaker stimulus. Okay? Any questions on that one? Okay? Which stimulus encoding, stimulus encoding sensory receptors respond optimally to
A.
Okay. I'm hearing A. The answer is A. As we saw in that diagram with the receptors, they all had very specific types of sensory input. Okay. Question 4. A fast adapting sensory receptor. Okay. A is the answer. It responds only at the onset and offset of the stimulus. Okay, like your clothes. Very good. Question 5. Vestibular system or vestibular receptors include Okay, A. All right. All 3 of these, well, no, these 2 are the proprioceptive system, and this one is hearing, and this one obviously is vision. Okay. Question 6. The semicircular canals detect I'm sorry, what?
E?
E?
C?
C.
Dang it. Okay.
So the answer is C. Remember, it has to be acceleration, deceleration, or changes in direction. That constant movement isn't. The otoliths, constant rotary movement, remember, is like that glass on the LP. Linear movement and vertical movement and gravity are all the otoliths. So B, D, and E are otoliths. Okay? Question 7. Which of the following is not true about lateral inhibition? What did I hear?
C?
A? C? Do I hear anything more than C? The answer is C. An illustration of this, and I don't think, did I do the cupboard with the door in this class? Okay. So if you're working in the kitchen and you have a cupboard door open and you're walking around and you bang your head, what do you do?
Laugh at yourself?
So what?
Laugh at yourself?
So someone said, cuss, and you may do that, but then I saw someone demonstrate. You reach up and you rub. So deep pressure is really good in lateral inhibition, and it decreases the sensation. So it helps. So if you have a Band-Aid, if you're taking a Band-Aid off of a child, if you give some deep pressure with one hand while you pull the Band-Aid off with the other one, it won't hurt as much because it actually inhibits that pain or tactile stimulation. Okay? Very good. Question 8. Which of the following best describes the pathways of the somatosensory system? So my answer is B. So these are the ones we primarily think of, but the face system is also included. So B would be the better answer. Okay. Question 9. Which of the following is true about the dorsal column medial lemniscal pathway? Pardon? Don't be shy. E. E is the answer. Okay. So E is the answer for 9. 10. Which of the following is not true about the AL system?
D.
Which one?
D.
D? Very good. The answer is D. Okay? So the AL system is much more local, can localize sensations much better than the DCML. So it can be more localized. So pain and heat, you can localize those often except for chronic pain, but sharp pain, you can localize those better than touch and pressure. They're much more localized on the skin. Okay? Question 11, which of the following is not true about
Can we go back to 10
Oh,
real quick?
sorry,
So the question was which was the following is not true?
which is not true.
And D says that the sensations
Oh,
in
you're
the
right.
AL system are localized.
You're right. So, you're right. So I will check into that.
Okay.
Okay? Yeah. No, thank you for pointing that out because I think I misspoke. So
Okay.
I believe that that the AL does not do it as precisely.
Okay.
Okay.
So the answer is
The answer is D.
okay.
Yes. Thank you for pointing that out. I misspoke. Okay. Question 11. Which of the following is not true about proprioception?
C.
Okay. I heard C, and that is the answer I have is C. Join receptors are the most important source of proprioceptive input. Okay? 12, which of the following is true about the tactile sensory system? Okay, I'm hearing B. B is the answer I have. The first class had some difficulty with this. The reason that I answered B is because the skin is the largest receptor, is why I would select that answer. But I agreed with them, the wording probably is not the best on this question. But the reason I picked B is because it's the largest receptor. Okay? All right. So what I want to do is actually stop there for the moment. And how many of you watched Emma, the video? Okay? So you will want to do that before tomorrow. And today, I'm going to stop there. But for Emma, you have thanks to score related to the sensory profile, clinical observation, and the sensory processing measure. So I'm going to stop with the slides and let you take time. You're welcome to do whatever you want. We won't come back together. So you can work here, you can work outside. I'll go through some of these, and just at the end here, don't forget that the DQR is due tomorrow night.
Is it like midnight or something?
It's 11:59.
Okay.
Yes. Andy already set it up. I saw 11:59. If it's after that, it won't get, it won't be successful. And then tomorrow I'm going to put up a couple swings. We're going to work more on the Emma evaluation, but then getting into a little bit of treatment for Emma. And if you haven't, take a look at this. It's great to show how a person with sensory processing disorder might feel. Okay? So go ahead and do your work that you want, and I'll see you all tomorrow. And remember, the afternoon lab's at 12:30, not 1. Okay? So I will be here if you have questions about the diagnostic assessment or your on Emma.